Dear students, I welcome you all to this digital electronics tutorial series. In this video, we will learn about how to find out the maximum number of Boolean function or truth table that are implemented using different number of random variables. So first of all, let us consider one single variable. So one variable. In the case of one variable, how many Boolean functions we may have? Sometimes you are asked to find out how many truth table we can have using suppose one variable, two variables. Okay, we will consider one by one. Finally, we will derive some expression so that we can directly find out the number of truth table. So first of all, let us consider one variable. Suppose the variable is capital A. So A can have two different values. One value is 0, one value is 1, another value is 1. Why we are considering only 0 and 1 values? Because this is a Boolean algebra and we have only two values, 0 or 1. Either a positive voltage is denoting 1 value or a negative voltage is denoting 0 value. So sometimes the opposite also can be configured. Here we are considering a single variable. This A variable can have either 0 value or 1 value. Okay, so let us find out how many truth table we can find out. So first of all, let me write down here. If we have A as the input, suppose y0, this is the output. A can have 0 as well as 1 value, because we are doing binary arithmetic operation or binary some functions we are implementing. So binary means 0 and 1. So 0 and 1, these are the two inputs. For these two inputs, we may have all the outputs 0. This is one case. Let us consider another case. A is the input, suppose y1 is the output now. So what will happen? 0 and 1, these are the suppose input. What will be the output? Output may be 0 and 1. Suppose for A equal to 0, output is 0, and for A equal to 1, output is 1. Okay, in this way we can consider. So this is the second truth table. Now let us consider again. A is the input and suppose y2, this is the output. 0 and 1, these are the two inputs. So we may have the outputs is 1 and 0. This is another truth table. Truth table means we are giving some input and we are respectively writing the output value. Okay, this is called as the truth table. Let us consider the fourth truth table, and y3. A is the input, y3 is the output. So 0 and 1, these are the input. You can have only two different types of values at the input, and y3 can have 1 and 1. We are considering four different kind of outputs for the same inputs. Okay, so these are the four different truth tables. So we can say that we can have four different truth table or four maximum number of truth table, or we can derive the expression for these outputs also. So let me write down here y0 equal to, so in the first case, irrespective of the input 0 or 1, we are getting output equal to 0. So y0 we can write as equal to 0. Okay, for the second case, we can write A. For y1 we can write it as when A equal to 0, y1 equal to 0. When A equal to 1, y1 equal to 1. So we can write y1 equal to, this is equal to A. Similarly, for y2 we can write the output function as, we can see when A equal to 0, output equal to 1, and when we have input equal to 1, output is 0. So this output is the opposite to the input. So here we can write, so y2 is equal to A complement or A bar. Similarly, for y3 we can write, irrespective of the input, output is equal to 1. When input is 0, output is equal to 1. When input equal to 1, output equal to 1. So we can write here that y3 equal to 1 irrespective of the input. So these are the four different Boolean function we have derived for the four different truth table. This is applicable for only one variable. So how many number of truth table can be made, or what is the maximum number of truth table we can make with single Boolean variable? So this is the number of four different types of truth table we can make, or we can say that the maximum number of truth table or maximum number of Boolean function using one single variable is equal to 4. Now let us consider two different variables. Suppose we have two variables, and what are the variables? Suppose we are having a comma b. A and b, these are the two different variables. So we have to find out how many boolean function we can have, or we have to find out the maximum number of boolean function, or we can say maximum number of truth table. We have to find out using two boolean variables. Okay, we have two input variables. Let me write down here. So we can have four different types of input combinations. Now we have two different variables, so we can have four different types of input combinations. So here we can write 0 0 0 1. This is another combination, 1 0 1 1. Okay, these are the four different input combinations. Now if we want to find out the truth table, what we'll have? Suppose for y0, similar to the previous case, what we'll have? Suppose for the y0, all the values are 0 0 0 0. This is one case. We can have, irrespective of the input, y0 value is 0. Okay, let me write down for y1. So for y1, let me write down here 0 0 0 1. Okay, this is the y1 output. Okay, this is a different output for the same input combinations. Next we have y2. For y2 we will be having 0 0 1 0. Okay, in this way we can write up to y15, because we will be having 16 different kind of output combinations. Okay, so let me write down here. So these are the 16 different kind of outputs we can have for these four different input combinations. So let me write down here on the left hand side. Suppose if we want to write down the product of some expressions for this input, what will be having? 0 means 0 plus 0. So 0 means, in the case of product of sum, it is, so we can write a plus b. Okay, 0 means it is not the complemented one. Next we have 0 1. 0 1 means it is a plus b bar. Next we have 1 0 is the input combination. For this we will be having a bar plus b. Okay, next we have 1 1, so it will be a bar plus b bar. Now let us write down the sum of product expression for these input variables. So we have 0 0, this means a bar b bar. Next we have 0 1 means a bar b. 1 0 means a b bar, and for 1 1 we are having a b. Why we are writing? In the case of sum of product, what we have, if we write a, this means 1 value. When we write a bar, this means 0 value. In the case of product of some expression, if we write a, this means 0, and if we write a bar, this means 1. Okay, so using these values we have written these boolean functions. Okay, now let us find out the expressions for y0, y1, y2, y3 up to y15. Okay, so that we can have the boolean functions. Y0, how we can write? All the output values are 0 irrespective of the input value. So for this case we can write as y0 equal to 0, so irrespective of the input value. Next, for the second case, for y1 we are having 0 0 0 1. We are having output 1 for only when both the input are 1 and 1. So we can write here y1 equal to a b. This is the sum of product expression. Okay, now for y2 equal to, so 0 0 1 0. How we can write? 0 0 1 0. So we can write it as a b bar. So because when a and b bar, if we complement the b, then we will be having the 1 value here. So here we can write a b bar. For y3 we can write y3 equal to 0 0 1 1. When a is equal to 1, the output value is 1. So we can write it as a. Next we have y4. For y4 we can write it is a bar b. Why a bar b? Because you can see a bar, if we do and if we multiply with b value 1, then only we will be having 1 value. So a bar b. Next we have y5 equal to 0 1 0 1. So what we can write? We can write this is equal to b, because we can see here y5 value is exactly same with the b input. Okay, so we can write here b. Are you getting my point? Now next we have y6 0 1 1 0. These are the output for XOR operation. So we can write y6 equal to a XOR b. Okay, similarly y7 equal to 0 1 1 1. So this output is the output for OR operation. So we can write it as a plus b. Here we are writing the product of sum expression because this is the simpler one. Okay, next y8. So for y8 we have 1 0 0 0. Okay, so what is the operation here? So this is the NOR operation. Okay, so we can write here a plus b whole bar. Are you getting my point? Now y9 equal to 1 0 0 1. This is for XNOR operation. So let me use a XNOR b. Next we have 1 0 1 0. This is the complete opposite of b value. 1 0 1 0, b value is 0 1 0 1. We are having 1 0 1 0. That means y10 is equal to b complement. Okay, next we have y11. So what we can write? All the values are 1 except the second row. So in the second row we can see, we can write it as a b bar. Okay, so then only we will be having y11 equal to this kind of values, a b bar. Okay, next let me write down y12. Y12 we can see 1 1 0 0. This is the complete opposite value of the input value a, because input we are having 0 0 1 1. So this is the opposite. Y12 is the opposite of the input value a. So y12 is equal to a complement. Okay, next we have 1 1 0 1. So this value is different, all the other values are 1. So what we'll be having? We can see the input values 1 0. So we have to make this 0. So what we have to write? A bar b. So irrespective of the b value, we can write a bar b. So I have made a mistake here. This y11 will be a plus b bar, not a b bar. So this value y11 equal to a plus b bar. Okay, similarly y13 is equal to a bar plus b. Next we have y14 is equal to 1 1 1 0. So we can see ab bar, or we can write it as a bar plus b bar. Okay, so this is similar. Next we have y15 equal to 1, because all the values are 1 irrespective of the input values. So these are the Boolean expressions for the different output values. Now we have seen for two different cases, that is for single variable as well as for two variables. So from here we can derive a formula that the maximum number of Boolean expression or truth table implemented using n number of variables is equal to 2 to the power n. Because you can see for two variables how many outputs are there? We are having 16. Okay, 16 functions. For one variable, what we have? We are having 4 output functions. Okay, so what we can write here? We can see one have two different combinations. So here we can write 1 to the power 2 to the power n. Here this 1 is the number of variable. Okay, n. So similarly for the two variables we can write here 2 to the power 2 to the power n. Here n value is 2 because we have two variables. I hope you are clear with this point. So whenever you are asked to find out the maximum number of Boolean function or maximum number of truth table, so you have to use this formula. So let me write down here. So here we can see maximum number of Boolean functions or maximum number of truth tables implemented using n number of input variables is equal to 2 to the power 2 to the power n. So this is the formula you have to use. Whenever in the competitive exam you are asked to find out, you can directly use this formula. You replace the value of n with the number of variables and you will be finding out the result. Okay, so this much for today. Thank you for watching. If you have any question, please put it in the comment section below. Also like, share and subscribe to my channel. Thank you.